Okay, Bismillahirrahmanirrahim. Okay, folks, we are looking today at the 2014 November paper. This has been requested by some of my YouTubers. So can you please do the November paper? And I was going to be doing my class anyway, my GCC class here. So here we go. Let's have a look at this paper. Okay, let's move forward. Okay, we're going to try to keep one page at a time, try to make it as big as possible so we can get them, so when you play it back on, it's nice and clear. Okay, answer all questions. This is the non-calculator paper, folks. Let's have a look how we can do this question. Remember, non-calculator, so keep your calculators in your bags. Let's make it a little bit bigger. That's better. Nice and big, the bigger the better. Okay, let's have a look. Okay, right, we need a pen. Okay, here we go. We got a pen. Right, let's go for a blue. Let's go for a 2. Okay. It says find the value of 6.7 times by 520. This is the question on place value question, the first question of the paper. Now, what we always do is we compare the question to what we were originally given. So 6.7 times by 520. Okay. Is that a bit too bright? Oh, that's the wrong one. Okay. Okay, that's okay. I want it bright, actually. Make it a little bit darker. That's it. Lovely. So the 6.7 Harun has stayed the same. And then we have 520. Now, it was originally 52. So we have multiplied 52 by, the pen is too thick. So we times that one by 10. So if we times the question by 10, we're going to have that feeding through the answer. We're going to times the answer by 10 too. So normally the answer would have been 348.4, but now it becomes 3484. Because this number 52 became 10 times bigger, our answer became 10 times bigger, giving us a new answer of 3,484. Now let's have a look at the next question. So let's write down the original question above it. So the original question was 6.7 times by 52 is equal to 348. Well, that's the original question. Now let's have a look how our question changed compared to the original one. So now 6.7 became 67. So we made the first part of the question 10 times bigger. That makes our answer 10 times bigger. Now the second part of the question was 52. So what did we do smaller? We made it 100 times smaller. So now we have to feed that through now. So from where we are here, we're going to go back by 2 places. So like for like. So the answer becomes then 34.84. Lovely. Okay. That's that one done. And we've done that one. Now this one involves division. Let's get our original question here. And let's change that so it looks like this question as much as possible. So we have 348.4 is the original value. If we divide it by 52, that will give us an answer of 6.7. All of them here I've manipulated here. Yes. We arranged it to make it look like this. So now you've got to compare the question that they've given us to what we have. So 348.4 became 348. So what happened to the question that became 10 times bigger, that number. So if we make the top part of the number 10 times bigger, the first number, okay, so we will have to make the answer also 10 times bigger. Now, the second number was 52 originally. That became 10 times smaller. Now, the number that you're dividing by, if you make that smaller, what effect does that have on the answer? Does it have the same effect? It has the opposite effect. When you're doing a division question, the number that you're dividing by, the bottom number, whatever you do to that, you do the opposite in the answer. So because we're making the 52 10 times smaller, is divisions on the bottom, you have to make the answer 10 times bigger. So we have to make another 10 times bigger. Okay, whoops, I didn't want to do that, but now mine looks nice anyway. Another 10 times bigger. Okay, so the answer then will become what? 670. Are we happy with that? Okay, for those of you who didn't get that right, can you please make sure if you show the working out? So Mr. Hamza, can you please show me exactly what you've done? Okay, let's move on. Okay, on that page, is there any more questions on that same page?
Yeah.
On the bottom. Okay, so we need to move down a bit. And this thing is actually in the way. I'm gonna move on. Okay, we go. What's now? Okay, here we go. Nice question here. Karen got 32 out of 18 in a maths test. It's a bit low for the maths test. Karen, come on, pull your socks up. Okay, she got 38% in English test. Karen wants to know if she got a higher percentage in maths or in English. Did she get it? So we got to answer that question. So first of all, let's start with this. 32 out of means divide out of 80. If you want to change this information here into a fraction, it looks like that. You want to change that fraction into a percentage, we have to do this. Traditional old school method of changing a fraction into a percentage. Multiply by 100 over 1. So let's do a bit of cancelling. So we divide this number by 10 and this by 10. So we cancel diagonally. Okay, now what will go into 8 and 32?
8.
Okay, how many times does 8 go into 32? So divide that by 8, divide that by 8. That's okay, we're happy with that? Now we multiply the top numbers. We have 4 times by 10, which gives us, and 1 times by 1 is 1. So and 40 divided by 1 is still 40. So 32, so the maths mark was
40%.
So did Karen get a high percent in maths and English? So we can say here Karen scored a higher percentage in maths than English by 2%. So she scored higher by 2%. Done. End of that question. Let's move on. Okay, right. Because here are the heights in centimeter of 18 children. Show this information in an ordered stem and leaf diagram. Please make sure you use a different color than what you use last. If you're using black last, you use a different color now for any additional or any correction that you please. Yeah, green or red. Right. Okay, are we happy with that, ladies? Okay. Show this information in an order. Now, look at the keyword here is. The keyword is order stem and leaf diagram. Okay, now let's have a look. I've made the text as big as possible. Where's somebody from over there? Yeah. Wow. Okay, I think what we'll do is just copy that table up there because it's just too far down. Okay, here we go. Right, let's just quickly. I don't think we're gonna work down there. Okay, now let's find straight here now. Hello? How many lines do we have?
2, 3.
One more.
2.
And one more down.
No.
That's it? Oh yeah?
Yeah. That's it.
Okay, lovely. Do you have a key as well?
No.
Okay. Right. So what we have now, we need to quickly do it ourselves a key. You always have a key. But I'll put my key up here. Why have I got a black? Let's get a blue. Here's our key. Did they give you the key there? No, but we should do a key anyway. So the key would be 998 represents 98 centimeters. So we have a key. Okay, now let's look at these numbers here. We have to put this into order stem and leaf. We have numbers starting with the 90s. We have numbers starting with the 80s. And we have numbers starting with the hundreds. And what else? Any other numbers?
11.
No, the starting point 80s, 90s, 100s, we have 70s.
No.
Is that it?
It's 8, 9, 10, 11.
Oh, yeah, all right, okay, lovely. So we have the 100 ones and the 110 ones as well.
That's it.
Okay, so on the top of 8 we can have 8,
9.
then
10.
9, and then
11.
and then 10, and then 11. Lovely. Okay, right. So for those of you who, let's just quickly put them down here rather than going through manually. So the first line we should have 8. So there are 4,
8, 9.
4, 8, 9. Where did that come from? Tell me. 84,
84,
88, and
89.
89. And then we put them in order. And the next line we should have what?
0, 0.
90. Another 90.
91.
91.
91.
91. 92.
93. 5, 97, 98.
Lovely. And they are all here. This one, this one, this one, this one, this one, this one, and this one. We're all happy with that.
Yes.
That's it. Lovely. And the last one we have the 10 one.
We've got 102,
102.
106, 108.
Lovely. And the 110 ones, 110, 105. Beautiful. That's the answer. If you got all those right, give yourself a nice tick. If you haven't got any of this stuff right, do it in a different color so I can see the difference between what you've done and what is the model answers today. Let's move on. Are we happy with that questions? We've got a lot to do. We've got to get cracking. Forget that. That's the time that was. Whoa. Okay. So we have Kalinda. Kalinda buys. Right, let's have a look. Kalinda buys X packs of current buns and Y boxes of ice buns. There are 6 current buns in a pack, and there's 8 ice buns in the pack. Kalinda buys a total of T buns. Write down the total. Okay. So she buys 6 current buns. Now, what are the current buns there? What letters are they? That'll give us 6x. And then the 8 lots of ice bun. So we're going to have 6 times by x plus 8 lots of y. And that will give us a total. So we can simplify that as 6x plus 8y. Okay, folks, I'm sorry for doing this really big. Hopefully it'll actually be better for you. You can see more clearly. And also, so when you're viewing these videos back on your phones, I mean, this is something I've been discussing with some of my, one of my YouTube persons who are following us on YouTube. It'll be easy to see on a smartphone because it's nice and big, the text. So we're not looking at a whole page at a time. We're just looking at each question, like expanding it as much as possible. So I'll be happy with the answer. So 6x plus 8y. Okay, did you get that right? Okay, lovely. Let's move on. That one's done. Lovely. Right, let's have a look. Right, we'll solve the inequality. 6y plus 5 is greater than 8. Okay, now for this type of question, we have to deal with the question as though we treat the inequality as though it was an equal sign. So even though this inequality looks a bit weird, inequality being there, we treat it like an equal sign. So we start at the y. So the y has been what? The y has been multiplied by 6 and added by 5. First action, second action. Opposite of add 5 is?
Minus 5.
Minus 5. So 6y is greater than 3. So that should be the first one. Well done, Mr. Saad. That looks good. Now, opposite of time by 6 is?
Divide by 6.
Divide by 6. So y is greater than 3 over 6. Y is greater than a half. So your answer should be like that. Okay, folks, please try to show working out. I see some of you, I'm looking around, I see some of you haven't got any working out or just answers written down. Can you show the working out? If you haven't got the right working out, can you write the right working out down now? And do it in a different color than what you've done in the class. Thank you. Lovely. Here's an inequality in x show on the number line. Write down the inequality. Okay. So here we go. So we can say here, and it's x. The line is to do with x. Okay. So x is greater than, what's it greater than? What's x greater than? Minus 3. Why do I put greater than not equal to? Because we have a empty circle, which means minus 3 is not part of the answer. X is greater than minus 3. Okay, let's change the color. Okay. And x is less than or equal to 4, which is over here. Why do I put equal sign now? Because the dot is solid dot, which means the 4 is a part of the answer.
So
Put your hand.
what if you put it the other way around?
That's just as good. So you could, oh yeah, that's a good thing. So you can write like this. Okay, good. Well, I'm glad you mentioned that. So any of those two variations, you can write them either that way around or that way around. So it's a double inequality. Okay. So put your hand up if you got that question right. So not everybody. Okay. Right, let's move on. Okay, right, here comes Steve. Steve wants to put a hedge along one side of his garden. He needs to buy 27 plants for the hedge. Each plant costs £5.54. Steve has £150 to spend on plants for the hedge. Does Steve have enough money to buy all the plants he needs? Now, for this kind of question, what we need to do, we need to multiply the cost by the number of plants. That's what we need to do, those two numbers. So, we have to do £5.54 multiplied by 27. So what we have here is a traditional long multiplication question. On the first line, we multiply everything by 7. And the second line, we multiply everything by 2. So let's go. So 4 times by 7 will give us 5 times by 7 is, add 2 is, 5 times by 7 is, add 3 is. Okay, folks, if you spot any mistakes, please let me know as soon as possible so we can edit it out. So don't have time to spend hours and hours on editing software. Right, what do we put on the next line? Nice big 0. Put a flower there if you like. Doesn't matter. 4 times by 2 is? 5 times by 2 is? 5 times by 2 is? Add 1 is? 11. Let's add them up. So 8 add 7 is 15. 8 add 1 is 9. That'll give you 4, and that'll give you 1. And we get, now, we have in our question, £5.54 times by 27. We have 2 decimal places in the question, so we will have 2 decimal places in our answer. So the question says he has £150 spent. Does he have enough money?
Yeah.
And the answer is?
Yeah.
Yes.
Oh my God.
So the answer here, if I get my pen, is yes. Steve has enough money to buy the plants. Okay, so he needed, they will cost him £149.58. Okay, we done that, folks? Calculation. You got it all there? Lovely. Let's look at the next question. The next question, as I'm looking at some of you, quite a few you got help on that in the lesson. So you already got a model answer already there. But that was a question I think quite a few people got stuck on the next question. In terms of like an idea of how to do it. What is the next question, folks? What is it? This one. Okay, whoa, that is just too big now. Oh, that's a bit better. And we'll have to squeeze everything on there. Nice. Okay, right, here we go. The diagram shows the plan of a floor. Diagram not accurately drawn, so you can't start measuring things on there. Okay, the area of the floor is 138 meters squared. Work out the value of x. So what did we do? Okay. Right, I showed you one technique that time. We can even do it a different way as well. Okay, I'm going to show you a slightly different way to what I showed you in the lesson. Let's see if this method is just as good. Right, here we go. Right, can we see the box which I'm overlaying on top of the original box? Right. So what we can do, we can think of this shape as, let's go with the line. I'll get that. Okay, what was your answer? 8.
9.
The answer actually is 9. But never mind, we'll go through it now. Okay, we can see here that this measurement is 15. Now, what is this measurement here?
8.
No, it's 11. Well done.
How's it 11? Oh, yeah, then the
Yeah, because you got 8 here, the height for the first part, and then you got another height over here, which is 3. You add them together. So 8 add 3 will give the total height of 11. Okay. I want to work out we want to work out the value of the x. So what do we do here? This is our idea. Ready for the idea? So we say the area of the big box minus the area of the little one. This little one here, the little one here. This is the little one in the corner. Will give us the area of oops. Okay. So we have the total area is 138, isn't it? Of the whole lot. Okay, that's lovely. Equals area. Oh, what's it doing now? Equals the area of the floor. Now, what is the area of the big box? Somebody give me the formulas, give me some ideas. Mr. Saf. There is my big shape is what? Length times by width, which is 15 times by 11. Minus area is a small little piece here. What is the little piece? It's again length times by width, which is x times by 3. And when I do all that, what should the answer be? The answer should be already given to us. The answer should be 138. So this is just another idea, another way we could have done the same question. So can somebody work out for me 15 times by 11, please? 15 times by 11 is 15 times by 10 is 150 plus another 15. That gives us 165. So 165 minus 3x is equal to 138. Now, if you want to work out the value of x, so how do we work out the value of x? So, first of all, because you've got minus 3x, I don't like minus 3x, I want plus 3x. Okay, that's nice, but take this way and take this that way. So now we have 165 minus 138 is equal to positive 3x. What's 165, ladies, at the back? Minus 138. What's 165 minus 138?
27.
Beautiful. That's lovely. I'm going to carry on the question over here because I've run out of space in the bottom unless I actually. Alright, I can do that as well. So the opposite time by 3 is divide by 3. So 9 is equal to x. So this is another way of looking at it. So if you haven't got that down, you've got another equivalent, that's fine. That's previous one. Yeah? Okay, this method of the turnover. Lovely. Okay, right. I think if we're gonna break now, it's time for Maghrib Salah. We'll pause the video and we'll come back. Huh? Go back up.
Yeah.
You wanna copy this? Okay, you finish copying this down. Just gonna pause our video. Okay, right. Question number 8, right, folks? Okay, please sit down. We're now going back to live. Okay, it says that A, B, C is parallel to E, F, G, H. Yes. The projector. That's normally a good thing to put on. I'll just read the question to you. You can read it from there. GB is equal to GF. Okay. So what that's telling you here, if GB is equal to GF, this line indicates that this length and this length are equal. Also, this angle here is equal to this angle here. These two angles are equal. Ladies, are we concentrating, please? Let's come here. Don't worry. I'll get bright in a second. So let's have a look at how we can find out this value here. In order for us to find out this value here, we need to work out this one. So let's have a look. Now, what do we know about this arrangement here? So this here, what shape? Oh, it's a Z. What do we call that mathematically? Alternate angles. So alternate angles are equal. So this angle in here is going to be 65. If this is 65, this is okay. This one will also be
65.
Now, why are these two 65? Because there's isosceles triangles. Okay, and then this one will be now 180 minus 65 minus 65, which will give us 50. And this angle here will be 180 minus 50, which will give us. So now we need to write all those things down and explain them mathematically. So here we go. I'm going to start writing mine up here because that's how much space I got. I'm going to use all the space available. Please write yours in the appropriate space underneath. Thank you. Right, here we go. Right. Okay. So what do you say here? The angle, it was BFG, big friendly joint. Angle BFG is equal to 65 degrees, which is equal to angle ABF. Angle ABF. Why is that? The reason for that is we say, what do we say was the mathematical reason? Alternate angles are equal. Alternate. That's the reason. Angles are equal. So each part we're going to state, we have to give a reason. Done. Lovely. Let's change color. Now, if that's why was this 165? We say here now angle FBG. FBG is equal to 65 degrees is equal to angle BFG. Okay, what was the reason for these two to both being 65? So when we say isosceles angles, so let's spell isosceles properly. Okay, we got squiggles in the table. Isosceles angle, isosceles triangle. Okay, and let's delete that. So that isosceles triangle. Two angles are equal. Okay, lovely. So now isosceles angles, those two angles are equal, yeah? So we explained this one, we've explained that one, and now we need to explain that one next. Okay, let's change color once more. Okay, what do we say now? We say angle, what was it? Angle BGF. Angle BGF. Okay. Angle BGF is equal to 50, which is equal to 180 minus 65 minus 65. And the answer, reason for that is the angle sum of a triangle is 180. So angle, remember this is angle and not angle, that's something completely different. Angle sum of a triangle is equal to 180. So that's the reason why we got that. Now, here comes the last point. This 130 is the x value. Let's change color once more. Okay. So we say now, angle x is equal to 130 degrees, which is equal to 180 minus 50 degrees. Why is that what we say? Okay, so let's see if anybody can remember the correct definition. There's an incorrect definition and a correct definition. Correct definition has got a few words different, a few letters gone.
Angles at a point.
Angle sum at a
point on a straight line.
Add up to 180.
Yeah.
straight line. Oh, where's that answer? Line
Oh my god.
is 180. Angle sum at a point on a straight line is 180. Lovely, beautiful. And that's all of question 8 done. Let's move on. Okay, okay, that's been recorded by the way, folks. I'm not gonna spend time editing out your language. So, folks, please, can we just control our mouth, please? Yeah. I want to show the world how much oafs we are. Okie dokie. Right, here we go. Jack. Okay. Jack wants to find out how far people live from the nearest supermarket. He used this question on a questionnaire. How far do you live from your nearest supermarket? Right, 0 to 2, 2 to 3, 3 to 4, and 5 to 6. Right. What did we find is the error with this, Mr. Honey? Number 1. So we have overlap
No units.
of the response boxes.
And no units.
response boxes. Lovely. Okay, let's change it now. And no units, i.e.
Miles or kilometers.
So, for example, kilometers, miles, meters, whatever. Okay, that's lovely. The next question says Jack also wants to find out how often people go shopping. So we have to now we want to find out how often people go shopping. Write a question Jack could use on his questionnaire to find out how often people go. Okay, let's do that then. Okay. Right. Okay. What is your question? Let's have Hamza. Hamza, can you give us a question, please? What is the possible question we could ask?
How many times do you go to the supermarket in a month?
Excellent. So we could ask how many times it goes have to go shopping. So don't go to supermarket because we go shopping from local shopping mall. How many times? Yeah, how many times a week? It could be a month. Okay, probably a month probably be a better, but I'll put the different possibilities there. How many times a month do you go shopping? So the shopping could be in, the big shopping or small shopping, doesn't matter.
Wow.
Okay. Shopping. Okay. Question mark. Now, what we need now is some response boxes. What happened to S? It's mashed.
Hopping. What happened when you were hopping?
No, it was S, but it got slightly deranged. Okay, so how many boxes did you have in your responses?
4.
4. Okay, 4/5 boxes is fine. Let's put some details now. Ladies, can we stop having our private discussion? Can we look at what we're doing here together, please? Thank you. So here could be what? What's the first one?
0 to 2.
2.
Yeah. And then 3 to 4. And then 5 to 6. And then 6 to 7. 7 to 8. 7 plus. No.
So how many times? Yes, that's not hopping. That is really shopping.
So you know in the exam,
See my teacher and he goes, that's wrong.
Hang on a second. Okay, folks, we're going to go back and do a little correction quickly here. Something's been spotted by one of the students. Our scale is slightly out. So it should be 0 to 1. So we got here. And then we'll have 2 to 3. And 3 to 4. Oops. Hang on 1 second. Okay. So 0 to 1.
Technically difficult.
Okay. And we have 2 to 3. Okay. Then we're going to have 4 to 5. And then we're going to have 6 plus. Okay, that way, because I think what's happened here initially, we had 0 to 2, we got an unequal scale there. So that's correct now, taking that out. Lovely. Let's move on. Thank you for that correction, Samara. Let's move down to the next question.
Oh, this is an epic question.
Okay, now, I can't actually do this question here on the computer screen at the moment. Okay.
Yeah.
Ladies, why am I keep on talking to you? Can we please settle down and look at the board, please, what we're doing? Now, what we need to do from here, from the C point, if you put your compass point here and you stretch out the compass point until you get like these points here. So you do an arc. Okay? And then from those arc points that you have from the C point, you now then do the other, you find the midpoint, which will be, I'm doing this as a, okay, well. You do the other ones where you do the other arcs, find the midpoints. And then what you do, now you'll be able to find the middle point. So that's like very kind of rough hand explanation, but I don't have the tools to do on the software. So from the C point, first of all, you do an arc that goes along A and B, and then you use those 2 points as points, and then you find the midpoint of those by doing those overlapping arcs. And then you, from each part that overlaps, you go through, it should go through C, and that will give you the perpendicular point at C. Okay, thank you very much for also bearing with me on that one. Okay, here we go. We have RIA. Okay, right. Okay, right. Okay, Okay, question number 11. Ria is going to buy a caravan. Let's have a look at the caravan question. Okay, in the caravan question, we should have an answer of 900. The total cost of the caravan is, oh, why is it 3? Is £7,000 plus VAT at 20%. Okay, I think it'll be good if we get to 10. Ria pays deposit £3,000 and pays 6 equal monthly payments. Work out the amount of each monthly payment. So first of all, what we need to do is work out the 20%. So first of all, let's work out 10% of 7,000. 10% of 7,000 will give us 700. If that's 10%, then we double it, and that will give us 20%, which is 1,400. So really, the cost of the caravan is £7,000 plus 1,400. That will give us a total price of 8,000. Oh, I don't want to do that. 8,400 pound. Now, 8,400 pound minus the 3,000 pound deposit. That gives us a balance of 5,400. Now we get 5,400, and we divide that by 6, and that will give us an answer of 900 pound. That's the end of that question.
So, can you go back?
Can you go back?
So we work out the VAT first of all, add that on, minus the deposit, and then divide it by 6. So that is the proper and full technique for that.
There you go.
Right?
Yeah.
There we go. Okay, right. Next question. Question number 12a. It says factorize 3e squared plus 5e. So that is really 3 times by e plus 5 times by e. Now what do we have as the common factor, Mr. Saf? E. So we pull the e out. And what are we left with? 3e plus 5. Are we happy with that, folks? So the answer over here is e, 3e plus 5. Next question, it goes solve. Okay, now before we solve this, what we need to do with the brackets on the left hand side, we need to expand the brackets. So 7 times by k and 7 times by minus 3. So we have what we have? 7k minus 21 is equal to 3k minus 5. Now, when we have a double-sided linear equation, what is the idea behind this? We need to get the smaller the k value towards the larger k value. So move the k's onto one side and move the numbers onto the other side. So we now have 7k. It was a plus 3k, becomes a minus 3k. We have a minus 5. The minus 21 was minus 21, becomes a plus 21. So 7k minus 3k is equal to 4k. Minus 5 by 21 is equal to 16. Opposite time by 4 is by 4 both sides. So k has a value of 4 ton. Okay. Nice, lovely, linear, double-sided equation. We should all be able to do that with our eyes closed. Nobody should be getting that wrong in this class. Okay, here comes the next question. Expand and simplify. Multiplying, add double brackets. So let's have a go at that. So we have 2x times by x first of all. 2x times by x is 2x squared. And then we have 2x times by... I don't want to do that. We have 2x times by minus 8 is minus 16x. Then we have plus 3 times by x is plus 3x. And then we have plus 3 times by minus 8 is minus 24. Lovely. So that gives us all together. Now, these don't change, these bits. But this bit will simplify. So we get 2x squared in the answer. Minus 16x plus 3x will give us minus 13x. And the minus 24 stays the same. And that's the answer you put over here. Okay, the next question. It says here, solve this question. Now we've got to work out the value of f. Let's go to the fraction first. Opposite divided by 4 is time by 4. So now you have 7 minus 3f is equal to 8. Now remember what I said to you before. If the thing that you're trying to work out is negative, move it instead. Make it positive. So let's circle now the minus 3f and take that to the side. Let's just swap side for the moment to make it positive. So we now have 7 was plus 8 becomes minus 3f was minus 3f now becomes plus 3f. We happy with that? Okay, now what do we do next? So the opposite time by 3 is?
Divide by 3.
So 7 minus 8 was what was it? Minus 1. Minus 1 divided by 3 gives us an answer of?
Minus 3.
Minus 1/3. Okay, if I did you get that? Do you get minus a third? Yeah? Minus a third. F is minus a third. You got that, honey? Quickly copy it down before I move on. Yeah, come on, copy it down then. If you didn't get it right, please copy it down now so you know what the right answer, the technique is. You should be doing that as we go along. If you haven't got the right answer, please copy down the correct answer.
So do we get a break?
Maybe we can have a break. Let's go. Let's do some more. Right, let's move around. Oh. Question number 13. Okay, express 180 as a product of its prime factors. There's quite a few different ways of doing this kind of question. The way that I tend to show my students is we continuously divide by prime factors. Now the first prime number is not 1, and then 2, and then 3, and then 5, and then 7, and not 9, and then, but normally when you're doing questions, we normally just dealing with these ones really. So 180, what should we divide it by? 2. That gives us 90. And 90, what should we divide it by? 2. That gives us 45. 45, now you can't divide it by 2 anymore now. You can divide it by 5. And that will give us, and 9, we can't divide by 5 anymore, we can divide it by 3. That will give us, and 3, we can't, can we divide it by 3 now? Still? Yes. 3 divided by 3 again is unstoppable. So we say 180 is equal to 2 times by 2 times by 3 times by 3 times by 5.
2 squared.
You can as well. Okay, of course you can. So either you write the answer like this in the original format, or you write 2 squared times by 3 squared times by 5. Any of those two answers format is perfectly acceptable. Are you happy with that? Okay, lovely. Let's move on. So Martin thinks of two numbers. He says the highest common factor of my two numbers is 6, and the lowest common multiple of my two numbers is a multiple of 15. So that's our clue. So the multiples of 15. Let's start with the multiples of 15. We have 15, we have 30, we have 45, and so on. And the highest common factor is a 6. Let's look at 6 now. What's the factors of 6?
2.
1, 2, 3, and 6. Because the highest common factor of my two numbers is 6, and the lowest common multiple of my two numbers is 15. Okay, now if we looked at 15 and 6. Okay, let's have a look. Now if I look at 30, 30 is in the 15 times table, isn't it? Oh, and if I look at the number 6, what is those two numbers' highest common factor? What's the highest common factor of 6 and 30?
6 and 5. No.
What's the highest common factor of 6 and 30?
5.
Okay.
6.
What's the highest? 6? The highest common factor of 6 and 30 is 6. And what is the lowest? It says lowest common multiple of my two numbers is a multiple of 15. Okay. So the answer here is 6 and 30. Okay. The LCM of my two numbers is 15. So question B is done. So we have that. We can have either 6 or 30, or we can have another particular answer, which is 12 and 30. Okay. So we can go for 6 and 30 or 12 and 30. Okay. Lovely. Are we happy with that? Oh, some of us are really tired. Okay, right, what question are we in now? 14. I think we'll do this question, then we'll have a break. Inshallah. Right. Okay, here we go. Suha has a full 600 milliliter bottle of wallpaper remover. I've never heard of a wallpaper remover. Bottle of it. She's going to mix some of the wallpaper remover with water. Here is the information on the label of the bottle. So it comes in 600 ml, and you got to mix that much for that much. It says the sewer is going to use 750 milliliters of water. Let's first of all write the information down. Now we need to mix a quarter of this. So let's work that out. 600 divided by 4 is equal to? What's 600 divided by 4? So a quarter of 600 is 150. So what she's saying is, for every 150 milliliters of the wallpaper remover, we have to use 4,500 milliliters of water. So that's wallpaper remover. Okay, we're happy with that information. Yeah. Now we only have 750 milliliters of water. So first of all, let's just do some little bit of manipulation. So let's divide this by 10. Divide this by 10. So what do we have now? 15 mils is needed for every 450 milliliters of water. My intention is to get from this number 4,500 to this number. I'm going to do in these steps. First we'll divide by 10. Now 450. What happens if you divide 450 by 3? What do we get? 150. What happens if you multiply 150 by 5? What do we get? 750. That's my idea. So I've made my way from 4,500 to 750 by first of all dividing by 10, dividing by 3, and then times it by 5. So I found a way to do it. So by cancelling down, then going back up again. Are you happy with that idea? So it's direct proportion. Now whatever I've done on the right, I must now duplicate it on the left. So 15 divided by 3 is 5. 5 times by 5 is 25. So it says how many milliliters of wallpaper remover should you use? And the answer is 25 milliliters. Let's go and recording now. Okay, lovely. Question number 15. The students in the class kept a record of the amount of time in minutes they spent doing homework last week. The table shows information about the amount of time the girls spent doing homework last week. So the least amount of time is 60. Now let's get ourselves a tool on that. So for 60, okay folks, who knows the scale? So where's 60? Okay, how many squares in from 50 to 60? 2.
Yeah.
Okay, why the 2? Because every 2 squares is worth 10. So I'm going to draw a line. Yeah, lovely. Now, what is the maximum time? They haven't told us the maximum time directly, but they told us indirectly by telling us the range is 230. So the difference between the largest and the smallest is 230. So what is 60? Okay, I need to go back to the tool. I need to undo that. So what is 60? Add this 230.
290.
That will give us 290, which is going to give us the maximum point. So let's get back to our straight line 2. Okay, so where's 290? How many squares before the 300? 2. Try my best to pull. Okay, my line's slightly dingy. Oh, that's better. Lovely. Okay, now we need to draw the box. To draw the box, we need the lower quartile and the upper quartile. Where's the lower quartile? Here, and the upper quartile is here. So 100 to 220. So 100 to 220. Where's 220, folks? Tell me now. Stop there. Stop now.
Yeah.
Stop. Okay, lovely. Now we need some more bars. And the bars. So we need to join that one. That one. Okay, lovely. Oh. Okay, right. Now, We've done the least amount. Here, folks, look. Least, most, lower quartile, upper quartile. What's missing? The median. Okay, let's get ourselves a bar. Do we have a bar? Let's change color. Let's go for a dark green. And where's the median? At 170, which is how many squares from the 150? 4. 4? Samara, how many squares?
4.
There. Lovely. Okay, beautiful. Let's get off this tool. We'll start making lines everywhere. Okay, are we happy with our box plot? That's approximately that's where you should have it. Okay, Mr. Hamza, can you quickly put yours in because you haven't done it yet? So them are the values. Okay, Mr. Junaid, can you quickly copy it up? I'll leave you and I'm going to pause the video for a second while you copy it up. Okay, right, we're now back to live now. Okay, right. Anyway, that's the topic for another day. Okay, here we go. There we go. There we go. Okay, remember the first box plot was for who? Was for the girls. This is the girls one, and this one is the boys one. Okay, now it says compare the amount of time the girls spent doing homework with the amount of time the boys spent doing homework. Okay, are we happy with that? Now, what do we need to compare? We need to compare the spread. And the spread is the interquartile range. We need to make a comment about the interquartile range. What have you realized about the interquartile range for the girls and the boys?
It's the same.
It is it?
Yeah.
The interquartile range for the girls is 120, and the interquartile range for the boys is
110.
no. Who knows the difference? So let's write that down.
120.
Let's have a look. No, hang on 1 second. Let me just hold my pen. Okay. What is the interquartile range for the girls? It's going to be 120. And interquartile range for the boys is? Has anybody worked it out for me? Has anybody worked it out for me? Ladies in the middle. It's beautiful. Thank you, Samara. Sorry, thank you,
It's 100. Thank you, Afira.
Frida.
You don't. Did you put my name? It's my name.
Tava. Sorry. Okay. Pardon me. Okay. Apologies. Okay. Compare the amount of time the girls spend doing homework. So what can we say? In the interquartile range, the boys are. The boys are. Okay. Okay. Right. At the back row, folks. I seem to be talking to myself. You girls have your heads down talking to each other. Right. I'm asking a question. Right. What can make me a comment about the interquartile range of the boys and the girls and give me a reason what it means?
The girls got 20 more.
Okay, so what's the significance of having a big interquartile range and a small one? The smaller the interquartile range, which means the better, the more consistent data. Okay, beautiful. Right, let's write that down in a nice, beautiful sentence. So first of all, let's actually make a comment about the interquartile range in the first place. So let's write down a comment. What can we write down for our comment? The boys. Okay, the boys have a lower. Okay, have you written that down, folks? Have a lower interquartile range of 100 minutes compared to
The girls which have.
the girls. Okay, that should be okay. Girls interquartile range of 120 minutes. Full stop. So first of all, we made a comparison. We've said that the boys got a lower interquartile range and the girls have got a higher. Now we have to put in second sentence and put into context what it actually means in the data that we have here. And as Rutaba correctly mentioned earlier, and I forgot her name, yes, apologies, even though I've been teaching 11 years. Okie dokie, let's get on with the rest of the question now. Okay, right, let's have a look. So, Rutaba, can you how would you formulate the rest of the question? What kind of sentence you say? What does it mean? So,
mean that the boys are more consistent in their spending homework time.
So we say hence the boys were more consistent.
What does that say?
Hence, the boys were more consistent in studying. So we're putting in context. In studying time. In studying. Oh. Than the girls. So hence the boys were more consistent in studying than the girls. Or you can even say studying for a higher number of minutes than the girls. Okay? But it's the consistency. So the boys were more consistent in studying than the girls were. There's more spread in the girls' data. Okay, are we happy with that? Should we move forward?
Do you only need to talk about interquartile range?
Yes, you need to talk about one type of spread. So you need to mention about the spread of data. You can mention about the interquartile range normally. Okay, or we can talk about, yeah, it goes if you get 1 mark for correct comparison of a measure of spread using the range or interquartile range. You can actually use the range as well, the range or interquartile range, and then you get another mark, and or you can talk about the medians. Yes, you can talk about the medians as well. The one was a higher median, one was a lower median. And then you have to give 1 mark to give it in context of the question which we have. Okay? So we've used the IQR and.
Do you know with median, what would you say about?
You said that the boys have a higher median number of minutes studied than girls, that's it?
Yeah.
So that will just be a point.
No, about relating it to the context. Is that it?
But when we normally rate in context, we normally IQR is the more popular one because that means more, it has more significance. Okay, ready for the next question? Okay, now this next particular question, okay, requires us to draw a graph. Okay, now plot the graph. Okay, I can't really do the question from here. I need to move the question down to here. I need to make this smaller. Okay, make it a bit more smaller. Okay, now we're gonna get a graph. Now, can somebody come out and just make your paper for a second? Right. When we plot our cumulative frequency values, we plot them. Do we plot them in the beginning of the age, in the middle, or at the end? The end value. So for 25 cumulative frequency, the end value is 20. So we go to 20 across the bottom and go up by 20. Now, don't forget, folks, because of the primitive way that I'm doing mine, I don't have any like special tools for doing curves and stuff. Mine is going to be like quite a bit of a rough sketch here. So we're going to have 20 is 25. Oops, 25. Okay, the next one, we have 30 on the age will give us a height of 70. Okay, mine's slightly off there, that one. And the next one, 40 is 138. So I'm trying to do as accurately as I can. And the next one is 50 is 175, which is up here. And the next one we have 60 is 186. And the next one is 70, which is 194. And the next one is 80, which is 200. Okay, this is going to be really tough now. I'm going to have to draw a curve through here. Oh, that's going to be a really hard freehand. Okay, using the software that I've got, I don't have like any tools for doing curvy bits. I don't think so. Okay. Right, so we're supposed to draw a nice curve through there. Okay, I'm not going to try to draw that curve. I'm just going to draw the curve through the last part. I need the last part of the question, okay? So folks, please bear with me. Can you draw your nice curves? Can you draw a nice curve through those? I'm just going to concentrate on the last 4 points. Okay, I'm just trying to draw through those points. I'm slightly out, folks, but please bear with me. Okay, that's not supposed to be that rough. Now, in order for me to do the actual question, the question says 10% of the workers at the factory are older than 65. All I need is that last part of the graph. So I'm going to get this now. 65. Where's 65 along here? How about there? So we've got to go up. 65 roughly. And we've got to go across to the line. And we're supposed to get something like this. Okay. Now, I want everybody to pay attention, please, folks. Right. Now, what I've done here, I've drawn that square to help me. Okay. So, 65 is here. Whoa, that was naughty. Okay, 65 is here. 65. If you go up to the curve and go across, we come to what? 190. How many people are here? From 190 to 200? 10. So 10 out of 200 people are the ones which are over 65 years old, yes? Okay, that's how you do on your graph. I'm sorry about the rough nature of my graph, but you get that kind of curve there, and it approximately comes to 190. So 10 out of 200. If we cancel that down, what do we get? 1 over 20. And then we change into percentage, because there's 1 over percentage. So divide that by 20, divide that by 20. So we get an answer of 5%. And the question said,
X is Graham. 10% of workers of the factory are older than 65. Is Graham correct?
so the answer is Graham is incorrect. So Graham is incorrect. There's our working out. So Graham is incorrect. As the percentage of workers over 65 years old is actually what? It's actually 5% and not 10%. Lovely. Did everybody get that part there? Did everybody understand the 10% why it's 5%? Okay, because when you go from 65 up to your curve and across, it's only got 10 people left in the top part. 10 out of 200 is not 10%. 10 people out of 200 is not 10%. It's actually 5%. So we show the working out, we show the lines and everything else, and that's our job done. And that's I've written my explanation here in the graph. Can you please write your explanation in the correct place? Yeah, because I'm on this page at the moment. Yeah, your explanation goes on the other page of there. That page. Done? So that explanation should go on. You just put it arrow there. Put arrow. If you put the explanation in the wrong place, just put an arrow for the moment. Okay, are we happy with that question?
Yeah.
Are we happy with the explanation? Remember, 10 people which are greater than 65 does not equate to 10%. So it's actually really 5% mathematically we worked it out. Okay, the next question we get fun with it. Last lesson. Trying to help the students get the right answer. Well, let's quickly go to the next question now. About 10. Right, let's make this a bit bigger. Okay, let's make it a bit more bigger. Okay, I think that's a bit too big now, so a bit too much. Okay, question number 17. Let's look for the keywords in this particular question. Have you got the pen tool? Okay, A, B, C, D, E, F, G, H is a regular. Keyword in this question is? Ifra, what's the keyword in this question? Regular. What does regular mean? All the lengths are same and all the internal angles are the same. Lovely. So if it's a regular octagon, okay, and they're giving the shape inside the hexagon. So we need to work out the angle. Which angle do we have to work out? KFE, not KFC. That's a completely different angle. Yeah, KFE. KFE is there. This is KFE here. This angle here. This KFE. Now, in order for us to work out this angle here, we do need to know which angle. Mr. Okay, you take what we do. We need to know this angle here and this angle here and this angle here and this. Now, what do we realize? KFE is the same as this angle up here, isn't it?
Yeah.
So these two are the same because of the symmetry of the shape. This one here is the same as this one. Are we happy with that, folks? That idea. So let's start working out these angles now. Now, this angle here is the internal angle of a octagon. So let's go. So we say n minus 2 multiplied by 180 divided by n. That will give us one angle of a regular polygon. Now, this polygon is an octagon. An octagon has how many sides? 8. So let's put 8 into n. Okay, folks, can we have the hands above the table, please? So, 8 minus 2 times by 180 divided by 8. Okay, what's 8 minus 2? Okay, so what's 6 times by 180 divided by 8? Does anybody work that out?
It's 1080.
Beautiful. 1080 over 8. Lovely.
Which is 1350.
Degrees. Yeah. So this angle here is 135. That's the internal angle of a regular octagon. And that one is the same as that. So that's also 135. Now, what is K?
You take that away from 180.
Oh.
Well, that's the 5 one.
Okay, to work out K, we do 360 minus
140.
140. So what is 360 minus 140? 220.
220. And then J will be 220 as well because it's the same.
Okay, now, hang on a second. Which one? So we know that, we know this, we know that. Now we've got to look at this angle here. Now, what do we have here? We said the shape inside is a hexagon. Now, if we do the same again, gents, can we focus on the question here? Okay. Okay, right, whatever that is. Alright, let's try that again. So the n minus 2 times by 180 divided by n. So now the n value is 6. Yeah, we're dealing with a hexagon, yeah? So we got 1, 2, 3. Okay, I'm sorry. No, that's a hexagon here. Pardon me. This shape here, what's the shape here?
220. Oh,
This shape is a pentagon, isn't it?
yeah, okay, it's 5 sides.
1, 2, 3,
4, 5.
4, 5. Let's put 5 in there. 5 minus 2 times by 180. Actually, we don't need to do this. We don't need to work out what each one is. So that'll give you 3 times by 180. Which will give you. So we now know that these angles, the green, the red one, and these other angles must add up to 540. Lovely. Let's work out the. Okay. Should we call this angle, for example, x?
Yeah.
If this is x, this is also x as well. So let's have a look. We could say here different color. Say x, add 135, add 220, add 135 is equal to 540. Beautiful. Now, so what are all these? If I grab all of these and I take the other side here, because minus. So we can say 2x is equal to what? What's 540 minus all of that?
50. 50.
490.
So it's 50.
50.
And then it's 25.
So then x will have a value of
25.
x is 25. Okay, Mr. Hani, are we concentrating on this question?
Yeah, so I already got it.
Okay, are we concentrating on how we explain here? Yeah? Good, excellent. So x is when it goes there, you must show all of your working out. So we need to start making some comments. Okay, what comment can we make for the first part? So we had 135. What's 135? Okay, so the internal angles. Let's write a comment here.
135
I need
is
some more
angle.
space.
It doesn't say you need to write that.
Yeah, just show you working.
Okay, for this one, just give me one moment. Let me just quickly check, please, folks. What question are we on?
17.
Okay,
You gotta show you working, so we've done that.
okay, we have actually. That's true.
You didn't say show you.
What the birth doing the child?
Okay. Actually, okay, folks, that's right. Because you must show all your working. Because nobody says reason. Okay, that's fine. So we got all our working as all done. That's lovely, and we've shown evidence so that we understand what we're talking about. Lovely. Okay, let's move on to the next question. Well done, folks. Okay, question number 18. Okay, question number 18. What kind of question is called similar shapes? Okay, so we have a trapezium here, the white one, and we have like a bigger trapezium.
Is that enlarged?
Yeah. So work out the length of AB. So what do we say? We say always the length of the original time by the scale factor gives you the length of the enlarged. Beautiful. I'm glad you remembered it. Okay, now what is the length of the original line and the enlarged line? So we say 12 times by the scale factor, which is the multiplier, will give us 18. So the scale factor is equal to 18 divided by 12, which is equal to, beautiful, 1.5. We can even write it as a top heavy fraction as 3.2. So now it says they work out the length of AB. We haven't done that yet. We just done the scale factor. Let's change colors again. Now where's AB? AB is from here to here. So we can say again, length of the original time by the scale factor gives you the length of the enlarged. What is the original length? Original length is 5. 5 times by 3/2 will give me the length of the enlarged, which is AB. Okay, right. Lovely. So what is 5 times by 1.5? What do we get, folks? Beautiful. So 7.5 is equal to AB. Okay, who got that one right?
That's one window.
No, that's right. Yes.
So do you have a pen? Mine don't work.
They're over there.
Double, pick up your pen.
Okay, here comes the next question.
A blue one, please. Yeah,
Okay, trapezium AEFG has an area of AEFG is the small one, is that right? Small one. Now we have another rule for area. What is that rule? We say area of the original multiplied by the scale factor squared gives us area of the enlarged. So AEFG is the small one, which is the original shape. So that one is, what is it? 36. Time by the scale factor squared. What was the scale factor? 3 twos. Give us the area of the enlarged one. What's the area of the large one? It's the area of A, E. No, the area of the. Okay, Hanson, we got to work out the shaded area. Okay, let's get rid of the last 2 bits here. Excuse me, please. Okay, let's work out this place shape first of all. Okay, so we have 36 times by what's 3 squared over 2? That's 9 over 4. If you cancel it down, divide that by 4, divide that by 4, that gives you what? That gives you 81. That's not the answer, folks. What we worked out the area of the big shape, the big trapezium. Which big trapezium is that? That's trapezium ABCD. ABCD. That's the trapezium we just worked out. Now we're going to work out the shaded area. So we said the big trapezium minus the small trapezium will give us the shaded area. Okay. Give us the shaded area. So what is the big trapezium? It's 81. What was the area of the small one? 36. 81 minus 36 will give us an answer of? Today would be nice. 45. And that is the correct answer. That is the correct answer. Okay, are we happy with that? So we use the similar shapes of the lengths twice and the similar area formula once. Are we happy with that so far, folks? Okay, if anybody's not happy, tell me. I'm going to try to make you more happy. Okay, can I move the question down now?
Yeah.
Okay, right, let's quickly work through that. Nice, lovely question here. Y is equal to 4 divided by x. So y is equal to 4 divided by a half. 4, that's half. 4 divided by half is 8. Y is equal to 4 divided by the x value. 4 divided by 4 is 1. And then 4 divided by 5 is, and then we have 4 divided by 8 is 0.5. Lovely. And let's put this on the graph. So on the graph, we should have something like this. Number 1, sorry, 0.5 is, and number 1 is 4, and number 2 is, and number 4 is, and number 5 is, and number 8 is. Okay, now I'm not even going to try to join that with a nice smooth curve. It's going to be completely and utterly wonky. Okay, folks, what you do need to do, you need to join those points up with a nice smooth curve. Okay, nice smooth curve, folks. Lovely. Okay, I don't even want to. Folks, should I try drawing them up?
Do the line where like.
Try my best. Whoa. Okay, lovely. Okay, folks, sorry about that, folks, but that's the best I can do at the moment. Let's move on to the next question. Okay, Mr. Hani.
Yes.
Okay, this question Hani's going to do for us today.
I think you understand myself.
Okay, that's good. And in that case, I'll do it then. Yeah, okay. Okay, right. Are we ready for this next question, folks? Yeah. Yeah, but how do you get there? Okay. Okay. Put your hands up if you managed to get to this question last week and you've done it and you got it all right. No, that's me doing the question for you. Yeah, that doesn't count. Go on. You done it by yourself?
I done it.
I done it.
What do you get?
I got.
I did red pen.
Okay. All right, let's read this question.
I got
We
one to write.
nearly finished now, folks. Let's read this question. Okay.
What's the last question?
No, we got a few more questions after this. If you don't finish on time, I'll complete the video and then you guys can watch it later on at home.
Okay. Will it be a question on?
Inshallah.
I got mine.
Are we ready?
I'm
Yeah.
gonna watch it.
Okay, the diagram shows a solid shape. The solid shape is made of a cylinder and a hemisphere. The radius of the cylinder is equal to the radius of the hemisphere. The cylinder has a height of 10. The curved surface area of the hemisphere is 32 pi centimeters squared. Work out, now here comes the key word. Total, some of you need to go sleep early. Surface area of this solid shape. Give your answer in terms of pi. Okay, not apple pie. This is the mathematical pi. Now they want the answer with pi in the answer. So you don't need to do any mad calculations with decimals without a calculator. Not chicken pie. Okay, let's go. So first of all, can somebody tell me from the front of the exam paper what is the formula for the area of a sphere, surface area?
Is it
A equals
A
pi.
equals 4 pi r squared. 4 pi. On the board, that's all I can say.
So surface area for a sphere is what? What is it? 4 pi r.
Square. Oh,
Now remember, we don't have a sphere. We have a hemisphere. So we have to divide ours by 2, because that's for a full. That's like for a ball. We have like the half of it. Yeah. Now we now need to. It says that the curved surface area of the hemisphere is 32 pi centimeters squared. So they have actually given us. No. They've actually given us the area of the shape here, part. Okay. What is that part? 32 pi. So all of this is equal to 32 pi. Now, what do we need to work out from this information here? Okay, what we can do. Okay, folks, from this information here, we need to work out the. No, we've done that. 4 pi r squared. We need to work out the what value because we don't know from here. What do we need to work out, honey? A radius. That's right.
Or diameter.
So first, we need to work out the radius. Okay, so 4 pi r squared over 2 equals 32 pi. Now what do we do first? Let's cancel. So divide this side by pi and that side by pi. What do we have now? Divide this by 2 and that by 2. So we now have we left with 2 r squared is equal to 32. Now we divide this side by 2 and that side by 2. Mr. Honey, pay attention. R squared. Yeah, you pay attention by talking to Harun. That's what we're doing. So r squared is equal to 16. Now, what's r going to be equal to? 4. Because the opposite of squaring is square rooting. So we've now, from the information they gave us here, and what we set at the equation, we've managed to work out the radius. So we've managed to work out this length here, the radius, and this length here, the radius. And the radius is equal to 4. Where is 4? Lovely. Now, we know the area of the curvy bit on the top. Now, do we know the area of the bottom? No. Do we know the area of the curved part there? We need to work that out. Okay. Right. Okay. Right. Let's have a look. Okay. So, now we're going to work out the area of the circle on the bottom. Area of the circle is equal to, remember this one here is the area of the sphere. Area of a circle is equal to pi r squared, which is equal to pi times by 4 squared, which is equal to 16 pi. We're leaving the pi in the answer. So area of the bottom circle, which is over here on the bottom, is equal to 16 pi centimeters squared. The area of the top part is 32 pi centimeters squared. Okay, now we need to work out the area of the curved part. Curved part, the cylinder part, yeah? Now, if we cut the cylinder, that curved part will make what? A rectangle. And the distance around here, follow this here. This around here will be actually the circumference of the circle. And the height is 10. So to work out the surface area of this now, we have to do the area is equal to the circumference, which is the length here, times by the height, which is 10. We need to work out the circumference of this circle on the bottom. Circumference is equal to 2 times by pi times by radius times by 10. So 2 times by 10 is 20. 20 times by the radius 4. 20 times by 4 is 80. So that gives us 80 pi. Now we need to add them all together. Let's choose. So we got to add what? Well, let's have a look. We got to add 32 pi with 16 pi with 80 pi. So we got 32 pi, add 80 pi, add 16 pi, and that will give us a total area of 128 pi centimeters squared. Beautiful. That's all done.
That was really fun.
Okay, I haven't finished yet, folks. I thought lessons over. When I said lessons over. Let's do question number 21. Sure, your parents won't mind you having an extra lesson. Okay, expand. Give your answer in the form.
This is the first one.
So 1 times by 3 is really tough. Mr. Honey. 1 times by minus root 2 is plus root 2 times by 3 is plus root 2 times by minus root 2 is minus root 2 root 2, yeah? Now, when you multiply a root by itself, it becomes the number inside. Now, I have minus 1 root 2 plus 3 root 2. So that gives us what? Minus, sorry, should we say it is plus 2 root 2. What is 3? Take away 2. 1. So the answer is 1 plus 2 root 2. It says A plus b root 2. A plus b root 2. So in that format, give your answer in that format. Okay, let's do a little bit few more questions. Okay, now. Now, when we raise anything to the power of 0, it gives us what? So that's 3 to the power of 0. Oops, that should be 0. Times by e to the power of 0. So that becomes 1. That becomes 1. And the final answer becomes just 1. Okay, the next question demands a bit more thinking. Okay, what we need to do now? Can you see a minus here? Can you see minus? Minus means, okay, for those you can't see the minus, let's make it a bit bigger for you. There you go. Here's the minus. Let's make it even more bigger. So you got no excuses. I can't see the work, sir, you know. Wow, that's beautiful. Whoa. There's the minus. The minus means reciprocal, means turn this fraction upside down. So we now get 25y squared over 64 x to the power of 6. Now we are still left with the half is still there. What does the half mean? Square root. So 25 square root and y squared square root over. Whoa. 64. I'm going to split the bottom one up because I can. Okay, now 25 square root will give us 5. Y squared square root will give us y. Y? Y. Okay. 64 square root will give us 8. And what is the square root of x6? X to the power of 3. Because x to the power of 3 times by x to the power of 3 gives you x6. And that is the final answer for that one. Nice and big. 400% enlargement. Whoa, what am I meant to do that? Okay, okay, folks, this part of the video has to be done separately. We had a little bit of a technical difficulty when I was making the original video. I was meant to complete this part of the video after the students had gone home. I did do that at my own timing, but for some reason it didn't record. So I'm having to do it again. So here it goes. Okay, this particular question here, Paul has 8 cards. There's a number on each card. Paul takes a random 3 of the cards. He adds together 3 numbers on the cards to get a total T. Work out the probability that T is an odd number. Now, this particular question is quite a long-winded question. I wanted to show you in the most easiest way. So what I will be doing in the lesson, in this video, is I will be pausing the videos at different times and putting on some extra notes to save time in the video so it doesn't feel like this question's going on forever. Okay, so let's have a look. So, where's my pen? The pen. Okay, we've got orange. Now, work out the probability that T is an odd number. So, let's have a look what kind of odd numbers we can make. So, we can have a 2, add a 3. So, this 2, add this 3, add a 4. So, 2 add 3 add 4. That gives us a total of, that's 5. 5 add 4 is 9. So, that's an odd number. So, that's one particular total. Now you have to remember, with these 3 particular numbers, 2, 3, and 4, we can rearrange these particular numbers in 6 different ways. We have 3 numbers, we can rearrange them into 6 unique ways. And I will just quickly show you what those ways are here. So we have, for example, let's have a look what we've done. Okay, so we can have 2, 3, 4. We can have 2, 4, 3. We can have 3, 2, 4. We can have 3, 4, 2. We can have 4, 2, 3. And we can have 4, 3, 2. Okay, so there's our 6 possibilities with those 3 numbers. When we have a 3 number addition, those three numbers can be rearranged in 6 different ways. So the probability of this event happening is 6. So let's write that down. So we can say here the probability of a 2 and a 3 and a 4. We have to multiply this 6 times because there's 6 different ways of it happening. That's one particular. Now let's change color here quickly and let's go to what else? What other numbers will make an odd number? So here's another one. So 2 add 4 add 5. So 2 add 4 is 6, 6 add 5 is 11. And this, because we've got another 3-digit combination, and that can also be done in 6 ways. Let's quickly do that. And so we can have this and the probability of a 2, a 4, and a 5. That can also be multiplied by 6. Okay, now what other numbers can we do? Right, let's have a look. Let's change color again. Let's go for this one. Nothing will use that one. Okay, blue. So we get 2, 4, 5. We can also have a probability. We can also do, oops, let's go to that. We don't do that. We can also do a 3, 3, 5. 3 add 3 add 5. Oops, should we add here? Pardon me, folks. So that will also give us 11. Now, because we got because the 3 repeats, okay, and the 5 happens once. Now, in this particular instance, we can rearrange 3, 3, and 5. That can happen in 3 different ways. Plus the probability of a 3, and a 5. This one we're going to time by 3. But 3 different ways of getting that. At the moment, if you want to play about with those particular numbers, please by all means do so. I've given an example for the first one. The second one is similar. And 3, 3, 5 will be 3 unique ways. Let's move on. Okay, if you want me to, I'll just quickly do right now. So we can have 3, 3, 5. We can have 3, 5, 3. We can have 5, 3, 3. And that's really all we can. That's all different variations of getting this 3, 3, and a 5 number. So that's why we said it's time by 3. So we got 2 of them by 6, and let's have a look at another one. Okay, another color. Let's purple. So we can also have now another one. We can have, we've done 3, 3, 5. We're gonna have a 3. Whoa. We can have a 3. Add a 3. Sorry. Let's do that. 3 add a 5 and a 5. So this 3 and this 5 and this 5, for example. Okay. 3 add a 3. Oh, this is going to be doolally for me, folks. 3 add 5 and 5. So that'll give you 13. Now, because we got again, we only got 2 unique numbers and this one's repeat, that will also only be happen 3 times. So probability of a 3 and a 5 and a 5 times that also by 3. And now let's look at the last but not least. We have another total. To get odd number, 5 add 5 add 5 will give us 15. Okay. Now that, because the numbers are all the same, will only happen once. So this is what we're looking at. So I've explained on top of here. Now we need to try to be very conservative with the space we have. We might need to move the page up a bit, but we're doing this as big as we can. Now let's look at the mathematics that goes behind it. So if you don't mind, folks, I'm just going to move the page up a bit to give me a little bit more space here, because I need space. You've seen all the numbers on top. If you need to go back, please by all means go back. That's beautiful. Okay, I'm going to scroll a little bit up. I'm going to cut the numbers by. Okay, I'm going to try to keep it in color, folks. So let's keep it in color. Right, and let's go back to the orange. Probability of a 2. If you look over here, 2 happens once out of 8. So I'm going to use as much space as possible. So 1 over 8. Once you take the first card out, you have, whoops, pardon me, folks. Once you take the first card out, okay, I don't really want to do that. You only have 7 cards left. When you take the second card out, you only have 6 cards left. This is a question without replacement. So the probability of 3, there's 2 of them. There's 2 of them. Probability of getting a 4, there's only 1 4. So we have here 1 and a 2 and a 1. Remember what we said is this thing can happen how many times? It can happen 6 times. Try to keep everything in the right order. Right, next. green. Now it's a probability of 2 and a 4 and a 5. So brackets, probability of 2 again is going to be, remember, we have out of 8, times by out of 7, times by out of 6, and then all of that times by 6. Probability of 2 is going to be 1 out of 8. Probability of a 4 is going to be 1 out of 7. Because we've taken one card out, we only got 7 cards left. Probability of getting a 5, it's 5 here, is going to be 4. It's 4 of them out of 6. Done. Let's quickly swap over to blue. Plus, now the probability of a 3 and a 3 and a 5. Now, remember what we said before? We have to keep this nice and tight. So the first one's going to be out of 8, times by the second one's going to be out of 7, the third one's going to be out of 6. So probability of 3 is going to be 2 of them. 2, and probability of getting another 3 is going to be now 1, because we've just taken one of them out. Probability of getting a 5 is going to be 4 of them. So you can see quickly now the mathematics is coming into life in the sense of what we in this question. Okay, mathematics. Okay, here comes the next question. Right. So you have probability of a 3 and a 5 and a 5. Probability of this, so again, same format is the first one, first pick. We have 8 cards, then we have 7 cards, and then we have 6 cards. So probability of the first 3 is going to be 2 out of 8. Probability of a 5 is going to be 4 out of 7 because there's 4 of them. And then once you take one of those out, we have 3 left. Okay, we're getting towards the last one now, the probability of a 5, 5, 5. Okay, all right. So that's going to be, remember it's there, again is 8, 7, 6, because it's without replacement. Sorry folks, it's taking this long, but this is trying to find the quickest way of showing you. The first probability of 5 is going to be 4 out of 8, then it's going to be 3 out of 7, and then 2 out of 6. And that, let me just quickly check, is that exactly what I'm supposed to be getting? Okay, lovely. Now, what we need to do, we need to start, remember this is a non-calculated paper, we need to start cancelling everything down, and then making fractions equivalent and simplifying, and then we finally get to the answer. Right, let's choose a color. Let's choose, for example, a red color for our universal cancelling. I think the 1 is a bit thick. Let's go for 0.5 now. Here comes some crazy cancelling now. You ready for the cancelling? Here we go. So we have here, so 2, oh, I don't really want to do that. Okay. Divide that by 2. Divide that by 2. Okay, so we get that. Okay, so we got all 1s on the top and a 6 over here and a 3. We can even cancel this 3 as well. Okay. Okay. We can just leave that. So just because of this 3, divide that by 3, divide that by 3. That'll give you 2 there. Here we go. Divide that by 6, divide that by 6, divide that by 4, divide that by 4. Okay, lovely. Okay, divide that by 3, divide that by 3, divide that by 2, divide that by 2, divide that by 4, divide that by 4. Okay, next one. We have 6, sorry, divide that by 3, divide that by 3, divide that by 2, divide that by 2, divide that by 4, divide that by 4. Okay, lovely. Right, next one. We divide that, oh, I don't want to do that. Okay, divide that by 4, divide that by 4, divide that by 2, divide that by 2, divide that by 3, divide that by 3. Okay, so we should get something like this. Let's have a look what that tidies up to. So we have now 1 times by 1 times by 1. Okay, we can also do a little bit more cancelling here. Divide that by 2 and divide that by 2. So cancel until we can't cancel anymore. So 1 times by 1 times by 1 times by 1 is 1. Then you got 4 times by 7. So 4 times by 7 on the bottom will give us 28. So the first one cancels down to 1 over 28. Lovely. Let's change to a, let's keep it cancelling. Let's have a look. That's all gone. That was a 1, that was a 1. Okay, that's lovely. You have 1 times by 1 times by 1 times by 1 is 1. And you have 2 times by 7. That will give us 14. Now we cancel these ones down. We have 1 times by 1 times by 1 times by 1 is again is 1 on top. We have 2 times by 7 is 14 on the bottom. That's lovely. That's coming nice. So we have 1 times by 1 times by, okay, hang on a second. We have a 3 here. Okay, well, that's fine. 1 times by 1 times by 3 times by 1 is 3. We have 2 times by 7 times by 1, which is 14. We have all 1s, times by 1 is 1, and we have on the bottom 7 times by 2 is 14. So we have 1, 2, 3, 4, 5. Okay, all the fractions are in terms of 14s and 28s, and we can quite easily make them equivalent, quite easily, by multiplying these fractions by 2, top and bottom, to make them equivalent to 28s. So now we have 1 over 28 plus 2 over 28 plus 2 over 28 plus 6 over 28 plus 2 over 28. And that gives us a grande total of, let's have a nice different color. Okay, let's go, we've done purple, we don't know what's close from. I think we need to go back to red. Now, if we add up all these numbers, we have 1 add 2 is 3 now. 3 add 2 will give you 5. 5 add this is 11. 11 add the 2 is 13. So that gives us 13 over 28, and that is the final answer. Folks, I'm really sorry this question is taking like forever, but that's kind of in the way, the easiest way I could really explain the question to you. And I'm glad I'm using my big 27-inch screen monitor for this, because it gives me a nice big working area. And I've been able to do it nice and comfortably. Thank you very much for joining us in this question. I'm going to carry on with the paper now. I've got 2 more questions to do. So apologies for taking so long, but I just wanted to explain each part to you, so you don't think also you missed out all the steps and we don't understand, we can't do it for ourselves. But here we go. Question number 24 now. We've got 2 more questions. Let's knock this paper on the head, and it's getting late and I'm tired. I don't want to go to bed. Okay, well, let's have a look. Where are we with my mouse? Here it is. Here we go. Here we go. Okay, lovely. Okay, question number 24. Okay, question number 24. A is the point with coordinates 1, 3. Okay, B is the point with coordinates 4, minus 1. The straight line L goes through both A and B. Okay, now it says, the question says that is the line of the equation 2y plus 3x minus 4 perpendicular to line L. So the line L is the line that goes between these 2 points. So what we need to do first of all, in order for us to check for perpendicularity, okay, we have a test. That test is this. The gradient of the first line, so the gradient of line L, times by the gradient of the perpendicular line, which is this one here, the second one, must be equal to minus 1 in order for them to be, one to be perpendicular to the other. That's a test that we have in mathematics. So what we need to do, we need to rearrange this equation here to work out the gradient, and we need to work out the gradient of these 2 points here. So the easiest one to do is this one here. So let's start away. Let's change the color. Let's go for orange. We have 2y is equal to 3x minus 4. Now remember, let's change again. The template is y equals mx plus c. That's our template for the equation of a straight line. Now we must have y, but we have 2y. So what we need to do, we need to divide everything by 2. So we now have y is equal to 3 over 2 x minus 4 divided by 2 is 2. So we can now clearly say that our gradient is 3 over 2. 3 over 2. Okay, that's what the line that's meant to be perpendicular. That's this one here. So we now know this. Oh, whoops. We know that one. We now need to work out the gradient of these 2 points. Now, this is x, this is y value. Now, in order for us to work out the gradient m of the line L is equal to the change in the y values divided by the change in the x. Okay, we can say it as y2 minus y1 divided by x2 minus x1. So if we take the top ones as the y2 and the bottom y1, and that's x2 and x1, we can do it quite nicely and quite easily. Okay, dokie. Now, so we start with the 3. 3 minus minus 1. 3 minus minus 1. X2 is the top one. 1 minus 4. So 3 minus minus 1 becomes 3 plus 1. That becomes 4. 1 minus 4 is minus 3. We can write that better as minus 3 over 4. So we have now we now know this one. ML is equal to minus 3/4. And this one is 2. So let's try the test. So ML times by M perpendicular must be equal to minus 1 in order for this condition to be true. So ML is, we just worked it out, as minus 3/4. We times that by the perpendicular gradient, which was 3/2. So minus 3 times by 3 will give you minus 9. 4 times by 2 on the bottom will give you 8. So we got a number that's close to minus 1, but it's not actually. So this here is not equal to minus 1. So it's failed the test. In order for two lines to be perpendicular to each other, when you multiply their gradients, you must get minus 1, and we have here obviously not got minus 1. So our conclusion to this particular question is the line, and the answer is no. No. The line with the equation 2y is equal to 3x minus 4. Another line is not perpendicular. Perpendicular to line L. Okay, that's done. Okay, folks, hope that's explained clearly. So we got some crazy answers. There wasn't minus 1. Okay, last question, and last but not least. Okie lovely. I'm going to try to join these videos together so you get a nice one big video when you revise. Okay, page down. Okay, I think for this one I'm going to need to zoom out a bit to make it just okay. All right. Okay, this is the last question, question number 25. The diagram shows part of the curve with equation y is equal to f of x. The coordinates of the minimum point is 3 minus 4, right down now. So this is transformation of functions. Okay, if you look at some of the videos, you'll see some more work on this. Now, this is your standard function, which is this, y equals f of x. So we worked out y is equal to f of x, and then we've added 3 as an end, like a at the end, after we've done the function. So what that does, okay, every time I try to draw a curve, it just goes crazy. So I'm just gonna like to draw some points for you guys to see where the curve should be. Okay. Okay, I'm going to try to put the lines so you can draw your own curve on it when you do your exam paper. So I find it very difficult to draw curves using my current physics, this like equipment I have. So it's going to move up by 3 points. So the graph is down by minus 4, and then we're going to add 3 to it. So what's going to happen to the coordinates is that 3 minus 4, the x value stays the same, so we still get 3. But the minus 4, we add 3, gives you minus 1. So that's the effect of the plus 3. So I see, apologies already for the roughness of this kind of dotted line, but just trying to give you an idea of what the graph way would go. So apologies, I'm just having difficulties in drawing curves using my current equipment that I have. And the software here doesn't really help me draw curves. So y is equal to f of 2x now, this one. When we put the 2 inside the function, what happens is, rather than this point being happening at x equals 3, that 2 is like it squeezes the function down. So that 3 then moves to 1.5. So we start getting the curve down here instead. So it squeezes the curve down. So now we have the point at 1.5 instead. That point moved to there. And the minus 4 stays the same. So I'll put the coordinates here. So it'd be now 1.5 minus 4. That stays exactly the same. Okay, the next question, which you can't see, I'll just quickly pop it up a bit. You can see now, for y equals f of minus x, okay, we'll leave that there, that's fine. Okay, let's change that. Now, when we put the minus inside the function, normally the minus outside is a reflection in the x-axis, but a minus inside the function itself is a reflection in the y-axis. So in a sense, we can get like, this kind of effect. So this original curve here will go across the y-axis. Okay, there. So now we can have this point here. Oops. So that will be now not plus 3, but it will be minus 3. The distance down will be the same. So it will reflect across in this mirror line. So the answer for that one will be minus 3, minus 4, and that's the end of the paper, folks. I hope you have found some benefit in this particular paper in terms of your revision for examination, and this has been requested to me to be done by some of the students, some of the people following our channel on YouTube. If you found this video beneficial, please forward the link on to your friends who can also benefit from the examination preparation. If you find any mistakes in there, please drop me a polite message and I will try my best to look at it and edit it if possible and to correct it. Thank you very much for viewing. Please give us some feedback on how this examination paper has helped you with your examination grade. It would be lovely to hear from my YouTubers. Thank you very much, and that's the end of this video, and inshallah we'll see you in the next video. Until then, okay, we need to stop this. Where's the stop button going? Okay.